Some jets extend for vast distances, well beyond the confines of even the largest galaxies. Now, in this image, you can see a curving trail of radio emission. And corresponding to that, there's a curving trail of electrons, extending for perhaps 10 million light years. That's a huge distance. Now, this curving trail of electrons could be confined magnetically, or by hot gas, or even by both. But as well as the curving trail, we also have to explain the emission itself, the radio waves, the light and so on. After all, without the emission, we wouldn't be seeing the jet at all. Again, we can't be certain of what's causing the emission, but we do have some ideas.
There are two ways this might happen. One possibility is that there are a lot of weak shock waves along the path of the jet, which manage to convert some of the bulk kinetic energy into random motions of electrons, which then emit the radio waves and the light. A second possibility is that there may be viscous friction where the jet, which is moving very fast, rubs against the external medium on the sides of it, which is of course not moving so fast.
Astronomers are certainly not short of ideas about how jets from galaxies might be sustained, nor indeed how they radiate. But there are still very few certainties. And this is not only the case regarding jets from galaxies, but also for the far more humble jets from stars at their births and at their deaths. How the jets are produced and how they are confined is still something of a mystery. What we think we do understand is the ultimate power source. In the case of stars, this seems to be the compact object at the center of the accretion disk. That's a protostar at star birth and a neutron star or black hole at star death. When it comes to the much larger galactic jets, the ultimate power source is not very different.
Massive black holes fill this bill. They can convert energy with 10 times the efficiency of nuclear power. We believe, in fact, that almost every galaxy may have gone through a phase where a massive black hole formed at its center and gave rise to a colossal outburst of energy. By studying these jets and the radio sources, we therefore have a direct way of probing what goes on deep in the centers of galaxies. And the study of these massive black holes is undoubtedly one of the most important and challenging issues in astrophysics today.
This field of astronomy is moving very fast. Our ideas about black holes and about jets from stars and from galaxies is constantly being refined as new discoveries are made with new and more powerful telescopes, matched by new and more powerful ideas. What we now know would amaze those radio astronomers of 50 years ago, and yet they too were working with the best equipment that they then had available. You know, it's a remarkable thing, but as we solve one set of mysteries, we often uncover others. And these will keep generations of astronomers busy for decades to come.